Okay, so hi guys, good evening and welcome to Network Kings. And today we are starting with the CCNA CCNA 200-301 batch. So Amir, over to you. You'll just start with the introduction and the concept that we decided to present in a today demo class.
Yep, yes, Gaurav. So, hello everyone. This is Amir. I've been training for more than 1.5 years, and today I'll be giving you an introduction of this, right? So let's start discussing about CCNA. For that, say, just give me a minute. Let me see how to share in here.
And Amir, the voice is also too low, so can you just check your mic?
Can you check now? Like, how is it now?
Mm,
I mean, I'm able to hear you really good. So,
yeah,
what?
good, good. We can now.
Okay. So, are you able to see the screen?
Yes, now it's visual.
Okay. Can you see something called as CCNA written network, Cisco Certified Network Associate?
Yeah, correct.
Okay. Just give me a minute. Okay, so basically today's class is all about introduction as an overview of what exactly is CCNA. I understand most of you here must be knowing what exactly is CCNA, but let's just try to understand what would you eventually learn in CCNA and what is the job market that you would get. How futile is this job market, or is it going to be a long-term profile or something like that? Okay. So first of all, the full form, as you see, it's Cisco Certified Network Associate. So before we go there, let's take an example of a bike. Let's say a company Yamaha, they make up a bike called as Yamaha R15. This is basically a sports bike. You might have all seen it, right, at some point of time. So this bike, let's say this company makes up this bike, and then they create a module, they create a training, they invite the mechanics to their workshop, and they train in them on that machine, on that bike. And once they certify that, it means that whoever certifies this exam basically is a certified mechanic to work on that bike or repair that bike or modify the bike, right? Similarly, like very similar to this, internet is made up of devices like routers, switches, firewalls, load balancers, forward proxy, reverse proxy, right? And there are different vendors in today's market which have their own devices. For let's say Cisco. Now Cisco have their own devices. Now they are in cloud as well. Now then Cisco has competitors such as Juniper, Fortinet have their firewalls, Checkpoint have their firewalls, the number one firewall, Palo Alto, right? So these people, all of them, they came up with the devices. So initially, Cisco grabbed a lot of market and they came with a study of their devices, which is basically called as CCNA. So when you study their devices, how a router works, how a switch work, how a basic internet setup looks like, and then you give your exams on that, and then you get certified as CCNA. It means that you are basically a person or an engineer who's capable of handling their devices. Now, is this a worldwide standard? Not really, but a lot of industrial market consider Cisco certifications as valid. Now, there are multiple more companies who have come into market like Zscaler, Netscope, who are cloud-based security providers. But on-prem, Cisco has taken a lot of market price, right? So that's something about CCNA. So it's nothing but a study of the devices which Cisco basically has developed in terms of managing the internet, right? The internet is divided into a lot of devices like routers, switches. So let's start with a basic overview. Today, the entire syllabus will be covering it in a 30 to 40 minutes just to see what all you will be going to learn, like LAN, WAN, then IP addresses, and then your hub, then what is a switch, what's a router. So let's start with the basic. As we all know about this, we must have studied these definitions quite a lot in our colleges, right? So LAN, a group of devices talking to each other over small geographical area. Now that's a theoretical definition, but a basic practical explanation of this is our college computer labs. We all might have at some point of time used our college labs, right? Just a second. So let's say you are sitting over here, okay, and you do a control P and you do enter, and you see magically this printer producing a paper with the same data that is present on your screen. Now, how is this possible? This is communication between two devices over a small geographical area. Now that's an example of LAN, group of devices or devices more than one talking to each other over small geographical area. Now the second definition would be your WAN. Now today is like more over theory. We would eventually go into labs like static routing, dynamic routing, then what exactly a switch CLI looks like, a router CLI looks like. Then let's talk about this. Let's say you were, okay, there's something wrong with my mouse. Give me a minute. Okay, are you able to see my screen now? Hello?
Yes, sir.
Yes.
Okay. So, like I said, that's the explanation about a LAN, right? You are here. Let's say this is me, Amir. Today I'm in office. I'm in college. I'm in college lab, and I can take a printout. Let's say I'm done with my college and I go to Bangalore, and then I'm somewhere here, and my college is back in my city. Let's say Hubli, right? So now I do the same thing. Like I do Control P, and I see that I'm not able to take a printer. That's because I'm not connected to it, right? So maybe I connect myself to a ISP. ISP stands for Internet Service Provider business. And then the college connects itself to internet, maybe Geo as a service provider. Now, based on the communication, like IP protocols or LAN communication, VPNs, using this, I do Control P again, and now I'm able to give a printout. Now, what exactly did I do? It's nothing but group of devices, one or more devices, talking to each other over a large geographical area or wide geographical area is called as WAN. Or maybe, let's say, I just click on Facebook here, right? And then this page appears. This again is the best example for WAN because Facebook data center is situated at some part of the world. And through the help of DNS, which gives me the IP address, which we'll study a bit later, I'm able to encapsulate a packet, basically frame a packet, and able to connect to the Facebook server with the help of routers or routing, right? Now, this is a simplified example of WAN, group of devices or one or more devices talking to each other over a large or a wide geographical area. Not necessary that you have to be in a different city. Maybe you're using two different networks, even that comes in WAN. You must be staying in one area of a city and your friend must be staying in another area of city, or maybe there is a server hosted in another end of the city. You're connecting with the help of an ISP. This also is an example of a WAN setup only. If you have any doubts, feel free to unmute and ask questions, okay? Now, like for example, let's say I know a person called as Afroz, okay? How do you recognize a person? You recognize a person by either his nomenclature, naming, right? Or physical appearances. That's how you basically identify a person. You either identify by his name or you identify as how does he look, how he appears. So these are basically two types of general like identification of a human or a person. Similarly, every host on internet, I'm not saying about computer, I'm not saying about laptop, I'm not saying about router, I'm saying about every host. Any device that is a part of internet is a host. Be it your printer, be it your scanner, or be it your laptop or a mobile. So any host that is a part of internet will have two forms of fixed identification. The first is called as IP address. The second is called as MAC address. Now IP address is 32-bit unique identifier. Now what is bit? What is 32-bit? What is bit? So theoretically, bit is the smallest form of data. So what is a bit? Bit is smallest form of data. Okay, we still don't understand what does that mean. So let's say before Geo interrupted the Indian market of internet was a bit costly. You used to go to your internet recharge shops and used to tell them, please can you recharge 2 GB per day or 4 GB per day or 100 MB per day. What does that mean, right? Bit is a unit of data, which is like the smallest unit of data. If I combine these 8 bits, it becomes 1 byte. 1 byte is equals to 8 bits. So 2 into giga into 1 into 8 bits is the amount of data. For example, you're trying to download a file of 8 KB. The smallest thing is the first bit. Basically, it's a unit. So together, this bit, together when you use 32-bit, when you use 32-bit amount of data, that is identified as an IP address. An IP address consists of 32 bits. Now we'll be dealing about IP address in detail a lot later, but for now, all I want you to understand is IP address is a unique identification of a computer which is local to a LAN. That no two computers in the LAN will have the same IP address. So it's unique at the same time unique locally within the LAN. It's 32-bit. That's all I want you to know as of now about IP address. Like whenever you hear IP address, you should know that it's an identification of a host. The counterpart, the second identification or the layer 2 identification is called as MAC address. Now MAC address is again a number or a data which consists of 48 bits. MAC address will sum up of 48 bits. These 48 bits are unique globally. IP addresses are unique locally, means within a LAN, two computers would not have same IP address. If he has 10.10, he can never have 10.10. It will be an IP conflict. They'll be unique locally. But in some other LAN, maybe there's another LAN in USA or maybe other part of India. There, any other computer can have 10.10. That's okay. But MAC address, they are unique globally, means no other MAC address can be copied. This is because of a standard that they maintain. So there's something called as organizational unique identifier, which is the starting 24 bits, which is dedicated to a company. For example, let's say Dell. Dell gets this initial 24 bits, and then they add their own unique 24 bits like this. This is Dell. Let's say my laptop is Dell Inspiron 15 5000. So this 24 bits belongs to Dell organization, which is given to Dell. And then this 24-bit suffix is added by the Dell organization to their laptop series. That's why this is first of all unique, and then this comes up to the second uniqueness. Hence, MAC address, which is given to one laptop, will be unique globally. And MAC address is always embossed on the NIC card. NIC card means Network Interface Card. You must have all seen it some point of your time. In your laptops, it will be seen. Network Interface Card. Now, how do you see a MAC address and an IP address? You can see it with the help of command prompt. So let's say this is a command prompt. You can open it with the help of Windows and then command prompt. Or you can open run like this and you can write CMD. You will get the same black screen. And if I write ipconfig and /all, and since I'm connected to Wi-Fi, this is my IPv4 address. This is my physical address or MAC address. The first 24 bits are OUI, Organizational Unique Identifier. The next 24 bits are the series number of the device or the model. So that's your IP address and MAC address. That's how you identify a host on the internet. Now we will be dealing in detail about this. IP addresses are not as basic as I explained. There are 5 types of IP addresses. They are private, they are public, and how do you derive them? They are derived out of 4 octets. Why is the first network 1? Why is the last network 25? So this all things we'll learn eventually. Now let's take, 4 devices talking to each other. Let's have a complex environment first. Let's say a mesh network. Let's say there's a NIC card, and I connect it like this. And I want to connect this laptop as well. So I'll install one more hardware NIC card. right? So this works fine. There's no issue in this. But this is hardware oriented. You need a lot of hardware. This is a complex design. If something goes wrong, you require a lot of deep troubleshooting. So this is fine. It's a kind of topology. But what if I tell you that instead of this complex design, let me introduce a device, the device called as hub, like this. And then you all connect to hub instead of connecting to each other directly. So what does this do? This work like a mediator. Instead of you connecting directly, you go via a mediator. So hub is like an intermediate device that does the work of a mediator. And let's say this is number one. I'm not using any IP addresses as of now. I'm just giving them numbers. So when computer one wants to talk to computer two, packet would go to hub, and from hub it will go to 2, right? This is hub. Now what is hub? Hub is the first intermediate device that does the work of a mediator. But there is a limitation to it. And because of that limitation, we called hub as dumb device. Now why do we call that? So let's say I'm training here, okay? And I want to talk to just this person, this boy one. So I call him out and I speak to him alone, right? So this communication is called as one-to-one. Now I want to just talk to the group of boys, excluding the group of girls. Or maybe you want to talk to the group of girls, excluding the group of boys. So this communication that is happening between me and group of people is a large amount of number, not one, more than one, but it is selected, right? And now what I'm doing is I'm speaking to all of you. So these are three different modes of communication. In networking, when one-to-one person talk, when PC1 talks to PC2, we call it as unicast. When you talk to selected many or a group of many, right? One to multiple people, but selected people, not all. Maybe these three, or maybe these two are from same college, then these two. Group of selected people. One to selected many is called as multicast. And then when I talk to all, right, this is called as broadcast. Always remember, there are multiple ways of communication, like there's anycast also, which we'll see later if required. But for now, there are three modes of communication. Unicast, one to one. Multicast, one to selected many. Broadcast, one to all. Now, how does that is relevant to hub being done? Now imagine this is one, or let's say this is Mr. A, this is Mr. B, Mr. C, Mr. D. Now Mr. A wants to talk to B, so he'll create a packet like this. Now this is what? Unicast. The packet goes and hits the interface of the switch. Technically, the switch is supposed to give it to Mr. B. But what switch does? It sends it to everyone. So it considers a unicast is equals to broadcast. Well, let's say Mr. A wants to talk to B and C. So instead of sending to B and C, it sends it to D. So even it consists multicast as broadcast, and broadcast also as broadcast. Since hub cannot differentiate between a unicast, multicast, and broadcast, we call it as a dumb device. And because of this feature, this limitation, it is now depreciated and hardly used like an amplifier. But moreover, hub is a depreciated device, means it's not much used in market anymore. It's not even used anyway. So hub is an intermediate device which basically helped us, but it eventually came out as a dumb device because it could not differentiate between unicast, multicast, and broadcast. Then what? We developed this hub to a further device called as bridge, and from there we came to a further device called as switch. Switch constitutes 30% of syllabus in CCNA. Though I'll be covering it in 5 minutes, does not mean that that's the only content of switch. It has so many things: STP, RSTP, switch learns MAC address, forwards, avoid loops. But for now, let's see what is a switch. Switch is an intermediate device that does the work of a mediator. Okay, pretty much like a hub, but it's intelligent. Can anyone guess why it is intelligent?
Because it can differentiate between unicast, multicast.
Broadcast, exactly. When 10.10 wants to talk to 10.20, hub switch can understand that this is a unicast packet and it would send it in a unicast. So basically, it's integrated with something called as ASIC chip, application specific integrated circuit. But it is intelligent because it can differentiate between unicast, multicast, and broadcast. For now, when as a first class or maybe as an introduction, as an overview to internet, when you hear the word switch, you should understand that switch is a LAN device which basically does the work of a mediator, nothing more than that. You study it in detail or you don't study it in detail, the basic work of switch is to be a mediator and connect the internal devices to each other. That's the main purpose of a switch. Though it can do many other things like VLAN tagging and all that, but that's a future things. For now, you can just remember switch as this. Now the next device is called as a router. Okay, you all might have come across at some point of a time in router. Now before that, let's take an example. I usually give this example so that it makes a lot of sense for you to understand and correlate. Let's say I'm staying with three friends. Let's say I'm staying with someone called as Ravi, Amir, and Faraz. Okay. So it's a funny example, but it's very relevant to your routing. You might remember it throughout. Okay. So imagine Ravi is cleaning the home. Okay, and I'm taking tuition. So let's say Mr. A comes and forgets his key and go. Ravi takes this key. Listen to the words. He goes to Faraz and he asks, "Does this belong to you?" No. He asks himself. No. He asks me. I say no. The moment Ravi get to know that something does not belong to our home, he literally throws it to the door, irrespective whether it reaches to Mr. A or not. Right? That's the behavior of Ravi. When he finds something that does not belong to his home, instead of giving it to the one it belongs, he throws it to the door. Similarly, let's say he got now my laptop. He'll ask Faraz. He says no. He asks himself no. He asks me. I say yes. So he gives it to me. Something that belong to the home, he'll give it to the home person. Something that does not belong to home, he'll throw it to the door. This is our home door. Same to same behavior is with your LAN and your router. How? Let's say 10.10, I'm avoiding the 00, is talking to 10.20. Or maybe I'll write it. 10.10 is talking to 10.20. This PC will do an AND operation and get to know that the destination 10.20 is within the LAN. So it will do something called as R, get a MAC address, and send it directly to this guy. This is called as LAN communication. Now let's say 10.10 wants to talk to Facebook, and with the help of something called as DNS, I get the IP of Facebook as 40.10. Now this PC will do the same operation again to determine whether the destination IP is a part of my network or not. The moment it gets to know that 40 is not a part of my network, the first thing it does it send the connection or send the packet to the default router. So what does a default router does? It acts like an exit interface to your entire LAN. This is your LAN, this is your WAN. So it's like an exit interface for your LAN. That's the primary focus of a edge router. That's what it does. It connects you to internet. It also does something called as routing, which we will see a bit later. So what exactly a router does? A router is a device or an edge device which connects a LAN to an internet. It's like a default gateway or a default exit interface of your LAN. It basically gives you connection to internet. Now you must be like, let's say you're working from home, you will call Geo and ask for internet. They come to your home and they'll keep a box, that blue color box. And you think that's your internet box, but that's basically your router. If you turn your router off, you'll have no internet, right? This router is like an internet connection to the people of the home, while this router will have outside connection to different routers, which makes it a part of internet. But router is like a default gateway or an exit terminal of your LAN. So that's an overview of what a router basically is, or what a switch is. Any questions here?
Oh, sir.
Okay, so I have few questions for you, right? So when you say like internet, what do you mean by that? What do you think is internet?
Network of networks.
Could you be a bit loud?
Large network.
Network of
networks.
network.
Network of network?
Yes, sir.
So combine the different network, that is called internet.
Group of devices can communicate with the network.
Okay. Group of devices can communicate to a network. Okay.
Connected through the link.
Okay. So maybe not exactly, but I'll give you an overview. Suppose I'm here in Hubli, okay, and I want to connect myself to internet. I'll get a geo connection. Now I become a internet user. Though I'm a LAN user, I connect myself to this and I get a public IP. I'm giving a very overview. Somewhere my friend who is very much interested into coding, he develops a website, and with the help of AWS, or maybe he buys a static IP for himself, and he somehow hosts a server. Let's say www. Networking.com, and he connects this to a switch, and this switch connects itself to a router, and he purchases a static IP called as this, right? So this is his LAN. This will be hosted on a private IP. And let's say you are sitting in your home here, there's another person sitting in your home here, there's another person sitting in your home here, there's another person sitting in your home here. So what are you basically? You are all a part of users. You're like users. You're connecting to a router, right? All interconnected. So if this person tomorrow goes out of picture or disconnects himself, will the internet go down? No. One particular user went down. This website called as Network Geeks, which is a part of internet. Let's say this router fails and there is no redundancy, no VRRP configured, and this router fails. You would just be not able to access www.networking.com. But does that mean your internet went? No, right? So what is internet? Internet is nothing but collection of multiple LANs. These are all LANs, right? This is another LAN, this is a LAN. I'm not being very specific, I'm not taking data centers and all, but yeah, that's all, right? You host a data center somewhere, that becomes a part of internet. You might have seen outages, right? You cannot literally consider internet as one entity. It's a combination of multiple LANs together, making it as like a connection WAN, or maybe together calling it as an internet. So yeah, most of you answered it correctly. It's a group, a large number of LANs together talking to each other makes it internet. Internet is not a single entity. It does not mean that Facebook went down to internet went down. Not really. Again, there are multiple things which are involved, like DHCP, DNS, and so much more, right? Any doubts here?
No.
Rest of you?
No, sir.
Okay.
No, sir.
No.
As a demo, since we have time, I'll just take one more topic, and then I won't go deep in that, but I'll just explain. Let's start with DNS, okay?
Sorry, what's the second question? You said you had two questions for us.
Sorry?
What's the second question? You said you had two questions for us.
No, that I pretty much covered in the first question itself.
Okay, cool.
Okay. So let's talk about a concept called as DNS. The full form of DNS is domain name systems or domain name server. Okay. So before we go there, let's understand how your mobile phones work. Let's say you have my number saved as Amir. Okay. And you go to a contact list and you type on my number and you dial, right? Or maybe you remember my number and you're able to dial. What if my contact is saved and number is not there? Would you still be able to reach me or not?
No.
But my name is saved, right? So why can't you reach me?
You don't have exact address.
Yes. When you say address, what do you mean? Home address or number or what?
No. When we said internet is a standardized communication, like I would say,
No,
like
let's not go to internet. Let's stick to the phone. This is a Samsung phone. So you have a contact list. In the contact list, you have saved my name, but you haven't saved the number. Would you be able to reach me or
no,
not?
no.
But you have my
No.
number saved, right? Name saved, right? So why don't you reach me? Because
Particular ID is not present.
no, your phone works on numbers, does not work on names. Isn't it? Can you reach someone by just their name?
No.
Exactly. You need numbers, right? Without
Yes.
number, your device would not be able to contact me. No matter you have saved my number or not, you need to have the number saved. Have you ever heard of Yellow Pages? Have you seen this, Yellow Pages?
Yes.
Okay. If you're from India, you might have seen that movie, that Babu Rao movie, the Yellow Pages phone call that he keeps getting, Star Galaxy Garage and all that. So what is this? This Yellow Pages is a phone directory. You'll have a name and a number associated with the name. Let's say a hotel, Hotel A. Hotel A's number. Then let's say your name, let's say a government office. All the numbers are associated here and the names are associated here in alphabetic order. Now, why do you need it? Why do you need a yellow page? As human, you might remember numbers, but it's really impossible to remember all the numbers. So you need someone to translate the names into numbers. And that is what Yellow Pages does for you, right? It's like a dictionary of names and phone numbers. Now, similarly, 99% similarly, your internet does not work on names. You must be thinking, okay, let me add Facebook here. You type Facebook, I'm connecting to Facebook. No, it's a name. Let's say you connecting to, some other website, like let's say example.com. You must be thinking, I'm connecting to this domain called as example.com or maybe neverssl.com. But you aren't really connecting to this website. What you're connecting is basically to an IP address. So your devices, your internet, they do not work on domain names. Instead, they work on numbers, which numbers are called as IP addresses. Source IP address being yours, destination IP address being the server that you want to talk to. Now, imagine I come and tell you that, hey, you know what, Abhinash, you need to remember this number. This belongs to Facebook. Or I'll say, hey, Aditya, you know what, you need to remember this IP address. This belongs to YouTube. Whenever you want to watch or see something streaming, you want to go to this IP. Now, how hectic is that? You would not really be able to. What if the IP addresses change? So much of complication. So how do we solve it? We need someone to store all the names, FQDNs, fully qualified domain names, with their IP addresses and help us whenever we ask them. Like, I'm a computer. I don't want to remember Facebook IP address. I'll go to this guy. Hey, can you give me the IP address of facebook.com? He says, sure. The IP address is 157.24.192.3.5. And then I connect to Facebook. Now, this Yellow Pages or this person who's helping me translate a domain name into IP address is called as DNS server. Domain name server. Basically, DNS given the FQDN or the host name gives you the IP addresses. For example, let's say I'll do this nslookup. I'll explain the command nslookup www.facebook.com. It gives me an IP. It says this is an IP address of Facebook. So what I do is I copy it and I open it here. See, I'm connected to Facebook, right? Or maybe something else. Let's say example.com. Okay, so cross origin. Okay, maybe anyway you understood the example, but basically it's the same thing, right? You enter an FQDN. This is FQDN, fully qualified domain name. This query goes to a DNS server. The DNS server will give you the reply. For example, it's a little bit too much to go into Wireshark, but yeah, eventually we'll go there. So that is what DNS server does for you. Whenever you say that I want to talk to www.facebook.com or google.com or any .com for that sake, you basically talk to a DNS server and you ask for IP address and then you connect to IP address. If you want to see it, you can see it here like this. Let's say I connect to example.com, right? I click here. This is where you're actually connecting to 93.184.2.16.34 on port 80. This is actually the main destination where your server is listening to. So your internet does not merely run on, there's someone on unmute. Jana, I think. Okay. So your internet merely does not work on domain names, but it works on IP addresses. And since you would not really be able to technically remember it and a server IP might change, that's the reason you need someone to translate the FQDN or the domain name into an IP address. And that is basically taken care by your DNS server. We will go further in this as required, but that's the introduction class that I had for today. Further, we'll be learning in detail about all other concepts like DHCP, how a DHCP works, what a packet of DHCP looks like, what is DHCP rebinding. We'll be even doing DHCP lab. We'll make a set of computers, talk to a DHCP server and do the required work, like get an IP for itself. We'll open Wireshark and we'll check how a DNS packet looks like, what is encapsulation, how a OSI model works, what is a TCP IP model. So yeah, pretty much that's the introduction that I had planned to cover. Any questions on DNS?
No, sir.
No question.
Guys, anything that you want to ask related to the CCNA, please. Today is a demo class, and that means from 20th onward, we are going to continue the same time, 9 o'clock. So whatever the doubts that you have, you can just ask me or Amir. We can help you with that.
Amit sir, I have one doubt. Sir, sir, the question is some customer are facing slowness issue.
Okay.
Okay. The bandwidth is good, no packet drops. Okay.
Okay.
No packet drops, bandwidth is good. No fluctuation is happened in ISP side, in our side. But still the customers are facing the internet slowness issue. What type of troubleshoot we are doing? What we have to take the steps? What is the exact issue?
What's your name again?
My name is Ramesh.
Okay, Ramesh, are you working somewhere?
Yeah, I have 5.5 years experience in networking engineer.
Okay. So the query is, how do you troubleshoot a slowness, right?
Yes.
So let's start with you. Let's start with a device level troubleshooting. Okay.
Yeah.
There could be a device level slowness. There could be inline device slowness. There could be a device doing SSL inspection, and then there could be network level MTU or MSS slowness, right? There are multiple attributes to this. You cannot say that, without actual issue, you'd be able to judge it. Let's say, for example, instead of using the optimum MTU, instead of doing path MTU and getting what the MTU should be, you are just using a normal MTU and there are a lot of fragmentations. No one is saying that there are packet drops, but I'm saying there is fragmentation. Of course, that is going to induce latency. Now, why there is fragmentation? You need to figure that out. Now, you remove fragmentation, you see there is still slowness induced. There is no fragmentation. First of all, packet drops is something which you should check. Now, packet drops, if you get, and you'll be like, okay, there are a lot of packet drops, you need to figure out why there are drops. It could be your inline drops, it could be, or also your ISP level drops. ISP does throttling at times, right? So you need to check why they are doing, or is it a server level drops, or is it a retransmission?
Amar sir, sorry for interrupt. See, sir, the no packet drops issue, the bandwidth is everything is good. Okay. ISP side bandwidth is everything is good. No packet drops, no fluctuation. But the user are facing still slowness issue.
Exactly. So I'm going there, right? Like, since it's not a practical issue, I'm just taking you through like what all you need to check. You have no packet retransmissions. There is no fragmentation happening. What's the bandwidth your ISP promised you? 1 GB or 100 MB? What is it? And what's the current usage? Are you choking your bandwidth? You really don't know that, right? That is something which you would need to check. So
Yes.
again, let's say your bandwidth is not choked. You have a lot of bandwidth still available. Are you doing SSL inspection in between? Is there a firewall that is tunneling your traffic and inspecting the traffic? If yes, have you bypassed the SSL inspection for that particular website and tested? Okay, yeah, I haven't done that. Is there any switch in between which is doing this drop? I've seen a switch basically dropping packets. So it's a lot of things that comes in picture, right? You would not be able to tell that this is the answer for it. That's where we sit and troubleshoot it.
Okay.
So I mean, if I ask you that, how would you answer it?
First of all, I will check that what is the bandwidth. After that, check the packet drops fluctuation. After that, I will communicate with ISP
No, after that
side.
you'll check if there are fragmentations. Then you'll check if there is any device which is inducing latency. It could be a firewall, it could be a router overwhelmed. Then you will check all the inline devices. Then it could be like a PC level issue. When you get to know everything is fine and it's an ISP level issue, then you involve ISP, right? There has to be issue somewhere. And that's your work. That's where you have to figure it out.
Okay.
Right?
Okay, sir. Thank you, sir. Thank you.
Yeah, no problem. Yes.
Sir, can you explain the router and the switch portion?
You mean the one that I already explained, or you want me to go deep into it?
Yeah, you already explained that.
Yeah, so like I said, right, you need an intermediate device which does the work of a mediator. So you had hub. Now hub basically did that thing. It connected multiple devices within a layer 1 communication. But like I said, it was a dumb device. It couldn't differentiate between unicast, multicast, broadcast. So we developed it into a bridge. Then we developed that bridge into a device called a switch. The name itself basically explains it's an intermediate device that does the work of a mediator, and it's pretty much intelligent. Now, why it is intelligent is because when 10.10 wants to talk to 10.20, this mode of communication is called as unicast. Switch understands that. It does not broadcast every packet like a hub. When it has to send from 10.10 to 10.20, it does send directly. When let's say you are talking to a multicast communication, switch understand that. It also gives you multicast communication. So basically, switch is an intelligent device that does the work of a mediator. On the counterpart, router is like a default gateway. What is gate? Gate is basically we gives you an exit. You want to go home out of your home. You need a door. You need a gate. Similarly, you have a LAN 10.10, 10.20, 10.30, 10.40, all connected to this switch. The switch has power in it. When I say power, electricity. Tell me 10.10 wants to talk to 10.20. Do you need internet connection here or no? Abhinash.
No, sir, no.
You don't need, right? Because you're talking within the LAN.
Yeah, switch dot. Switch.
Let's say this is a geo router which is turned off. Geo router is turned off. Layer 2 switch is turned on. Can 10.10 talk to 10.20?
Yes, sir, because it's on LAN network.
Exactly. Now 10.10 wants to talk to 10.40.10. Without this router, will you be able to talk?
No,
So
because
what is this doing to you? Is it not like a gate to your LAN?
yes, sir, yes, sir.
Exactly.
Because
So you're
without router, router means used to connect two different network.
exactly.
When you switch off the router or disconnect, it will not communicate.
Exactly. It's basically just like a default gateway. Without default gateway, you would not be able to go out of your LAN.
Yes,
So
yes.
router on basic definition is a default gateway that connects a LAN to internet. On counterpart, a router does a lot of things like routing, access control list, multiple things it does. But
Yes, yes.
primary focus is of routing and to connect a LAN to WAN.
Yes, sir. Okay, sir. Thank you.
Okay.
The
Any
complete
other?
training will be in English, right?
Sorry?
The complete training will be in English.
Yes,
only.
guys. So
Yes,
this is
yes.
English batch only, and Hindi batch. We are running a 2-3 batches in a month. So this is an English batch, and in the month of Feb initially we are going to start with the Hindi. But yes, this is our English batch.
Yeah. I want to confirm that.
Okay, so thanks, Amit, and hope guys you like the session, and we'll continue from
Excuse
20th
me,
onward.
guys. Excuse me.
Yeah, go ahead.
I raised my hand long time ago, and that's fine. Okay,
Okay.
so I sent Amir a text. Did you saw that? Because if you have answer for that, please.
You sent an emails or you sent a message?
No, text.
Hello, Amir. Can you please give me the classroom ID shared by your teacher to enroll in this class? I think Gaurav would be able to answer that.
Amir, sorry. One minute, let me read
Ahmed.
here.
Yes, sir.
Is there any classroom ID, Gaurav?
So guys, this classroom ID, you'll get it in the portal from 20th onward. Today is just a demo session. We invited all on WebEx, but from 20th onward, you're getting a one classroom ID which you have to enter while entering to the class. Okay?
Okay. Thank you.
Okay, guys. Thanks.
Time for the fees.
Thanks, Amy. Yep. Bye-bye.
Bye. Thank you. Thank you for your time, guys. Bye.
Thank you.
Bye. Thank you.
Thank you. Bye.